Hello. So, just getting everything set up. Gonna have to change my music. I have some really energetic metal music playing, which isn't entirely appropriate for concentrating. So, I think everything's looking okay. I tend to whack my microphone too often. Okay. Um. Right. So I need quieter music so I don't feel like I'm in the middle of a rock concert. Let's see, what should I put on? Oh, this is perfect. That's perfect. Okay, now I can hear myself think, which isn't always desirable, but it's definitely desirable right now. Okay. That's good. Um, Let me have a think for a second. So we need to continue with our worker system. I really need to like speed up development on this because I obviously push it off until I have time to stream it, and so I do actually desperately need it for several projects. Now, in saying that, I did go away after the last session, and I reviewed the DAL setup quite a bit, and I've implemented a new DAL setup. So, I have the whole Otter set up now so it can run locally. We're going to keep it to SQLite primarily for now. But the DAL setup is now more in line with what the registry does, because last time I got myself into a little bit of a confusion, I guess, of how I wished to set this up. But it's now all wired in, and it should be wired in basically the exact same way as the registry and the orchestrator currently is. So it doesn't set in a mandatory database. We're not going to be using this wiring just yet because this is the developer-facing wiring. But I like to think of the full end-to-end flow sooner than later, if that makes sense. Because then I can concern myself with making sure everything is aligned with what I want it to be. And so future decisions don't shoot myself in the foot. So, and we have. Oh, this is scrolling fast. That's a. Why is that scrolling? Oh, now it's not scrolling fast. Okay, when I. Oh, that's interesting. If Z is your not your currently selected window, it zooms the scrolling, and then when you select it, it slows down the scrolling. That's odd. Um, I was just pausing because I can feel the fans on my computer going off, but it's just because of OBS. So, yeah, so we have, I got it set up with Postgres and SQLite and now Otter. So we have our nice uniformed DAL to interface with. So the main thing today is our worker system, it only does stuff, which is, you know, everything does stuff, but it only does stuff when asked to do it. And I think that's the biggest problem with what we've built so far. Is for a real worker system, you want control of what is working when. And additionally, if something is no longer working, for it to obviously be able to properly record that fact. Now, we do have the whole retry mechanism, which does reschedule something, if I recall correctly, with a backoff. Let me remind myself with how it actually works, what we have. So once again, this is our worker system. This is, for the most part, what a developer writes when they're using the framework to be able to create a job. And this is the test that obviously they don't write, but handles the test, the scaffolding of the job. Because if I recall correctly, we don't have like a nice way to say, can you run this? Can you run this in the future? Can you snooze on this job? Can you wait on this job? That type of thing. And that's why the first thing we're going to have to do is start adding options to the spec to give us the basis of control going forward. Let me just close everything because yeah, I think the key thing is that all we can do is we can just enqueue. There's no pause, there's no wait, there's no way to pass in a delay or anything. The only way you could technically do that right now is by setting a timeout of like 0 milliseconds, then you hit the back off. And so what we're going to want is control. I know one of the core things I'm going to want also in the future is be able to schedule jobs. So you'll be able to say, run this job every night at midnight, for example. That's not the priority of what I'm going to do right now. I think the first point is just having basic control of time from a developer point of view. But having like cron type functionality, I think is kind of essential going forwards. So see how my audio is So I thought we... Just checking for a second, so I thought maybe it went too red when I was speaking. Test, test. Nothing's fine. Test, test. Okay. I have to look over there, this monitor, to see. And, okay. We'll see how bad that is. Maybe it's too bad. Maybe I should move this slightly down. Test. Test, 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 test. Okay. Okay. And the other core thing is there's no way for people to be able to control priority. Because that's fundamental. Thank you, request. Yeah, there's no way for people to be able to say... I'm now pausing because I deviated these two structs. Because they had technically different purposes. And I'm pausing for a second because are they actually meant to reconvene? I think not, because I think the ID is never part of the request. But I can see these trying to reconvene a bit more, because ultimately this is... We need scheduled at, we need priority in the request itself. Now, if I recall correctly, did I even set up a dead letter queue? Dead letter... Because a dead letter queue is also a concept we're going to need to scaffold. And it should be that using the store, you should be able to check the whole hexagon. Retrieve a list of all items in the dead letter queue, so then you can re-trigger them from the interface. I might want to add that to my list if it lets me. Worked. Dead letter queue. Because that's going to be important. We will need a good dead letter queue. It's essential for a good interface. Just having a think if there's anything else before we really start diving in with the implementation. If there's anything else I should consider before we start. I'm thinking aligning these two things as much as possible may be actually needed. But we don't even interface with the enqueue request directly. Because that's inferred from the options you give it. And that begs the question of what should the developer experience actually be when you want to schedule something or snooze something? So I think the idea of what we want to do with snoozing is a way for a job to be able to record that it itself is wants to wait, right? And while it's waiting, is not using any CPU. So it's like a lightweight snooze. We might want a new file for this. I don't need welcome marks. I don't need that again. That's fine. So we can say snoozing worker. Just trying to have a think about how this is all going to work together. because snoozing would contradict locking. Ultimately, this may just be a bad scenario here. Let's say we had a snoozing worker. An example could be... So let's say the snoozing worker hit some sort of mail service. Like mailer, say mail. And let's say, I don't know, yeah, message. Like that. So let's say we... Just having a think how this could work. Rates limited. I don't know. Ooh. Because then, conceptually, you could say something like, if I'm rate limited, that's when you just say return w dot snooze. I'm just trying to figure out where the control should live. I think it should actually just be a general method and not anything related from the function. So it should come from the facade. And then you'd put in a timeout for it to retry this job at. So, you know, you just say 1 times time dot hour. And then something like, I mean, obviously I know this doesn't work, but then you'd be able to come back into this in an hour's time and then send your message. Or alternatively, which might make more sense, I don't know. You would do it like this. if error doesn't equals nil, I don't know. How did I decide to handle errors? Just normal return error, right? Yeah. Format.errorf. Failed to send message. And then this would obviously be, checking if the sentinel is whatever the rate limited sentinel is. But then, yeah, if you're rate limited, you'll snooze an hour. You won't hit the normal back off flow because the reason why you wouldn't hit the normal back off flow is because here you could actually code it in, right? So like you could be mailer dot wait time, right? Or run after whatever. Now, obviously, this doesn't work because I have to implement the interface. Doesn't do anything. Hey, Maestro, how you doing? But I think conceptually this is what I'm looking for. I might have to actually implement this so we can really test it. So we could give it a sentinel. Err. I am rate limited. Errors.new. I'm in that phase of getting started where I need my brain to warm up. Um, you, So what we should do we want to make this deterministic. Let's say, I don't know. Tempt if attempt equals 1, return whatever. Otherwise, there is no error. And we could not do anything. So snoozing worker, mail, blah, blah, blah. You want attempt, so we should store that. I'm just thinking because obviously I want to avoid using a mutex here. Oh, God, actually, in saying that, there shouldn't be a problem with how I've implemented it for using mutexes. There shouldn't be a problem. So I need mutex. Because snoozing, that's the whole point of the snooze architecture, I guess you could say, is it doesn't maintain resources, so it doesn't hold onto memory. That's the idea. So say attempt this would mean attempt would start at whatever. Attempt. Okay. I need to get my brain juices flowing. I can feel my brain just not engaging yet. So yeah, so we're gonna have the snoozing worker. If attempt is less than 2, because it's instantly gonna be 1 with how I've coded this, then we're going to return the error that it's been rate limited. Got a fly in the room. If errors is, then we could just say error, error I am rate limited. The actual message doesn't mean anything or do anything, to be honest with you. But then we would snooze. And with how the with how it's going to be built, the lock system should still work because it will release the lock even if we snooze. Because snoozing is going to be light. It's going to be lightweight. It's not going to hold onto resources or memory. I suspect the mailer could actually tell it how long to snooze, like how long is rate limited for. So, That conceptually would make some sense. So let's say it's recording that it's 1.time. Well, let's not make it a now because that's going to be terrible for testing. Let's just say second. Zero. I've been looking at C all day, so my brain is mush. My brain is mush. Yeah, and then we'll say timeout duration. Okay. So this is what I'm thinking. Nothing too complicated. But we'll have a basic mailer, and then we'll be able to call this. Let's try and find just like the basic. Retry then succeed. Let's try this one. So we'll call this one snooze then succeed. So mailer. So this won't work, obviously. Hold on. Do I want to record anything else? Attempt. I mean, I could. Yeah. Attempt should be 3. So it's going to go through. It should snooze twice and then work, right? And it should work eventually after the 3rd attempt. And it should take about 3 seconds to run once we've implemented this. Okay. Before I start with the implementation, let me just take a moment to think that this is what it is I'm planning to do. I'm thinking that I might want to concern myself with a lot of the scaffolding going forward, as I was saying, with also handling data and passing around data. Is a snooze a failure or is a snooze a snooze? Can a snooze become a failure? Is a snooze a retry? Or not at all? Does a snooze increment attempts? Or is it the same attempt that snoozed? These are all things I'm going to have to think about. The core thing is, I think this has to be made visible to the store in some way. So you will be able to see jobs that are currently snoozed in the GUI. So however we do this, we don't want to hide it behind existing machinery and then make it difficult to detect between snoozed and, unsnoozed, right? It has to be clear that something is scheduled out in the future because of a snooze. I think. I think the key thing is that snoozing is control. It's not a failure flow. It's explicit, it's intentional, it's controlled by the developer. So I'm thinking that it's the same attempt, even though it's a different execution of the same function, of the same job, it's the same attempt. But then in doing so, am I losing observability? Like someone may want to know how often something's snoozed. Because, like, if I'm being rate limited, I might want to know how much I'm being snoozed. The only reason why I don't use the attempt machinery is that the attempt machinery is what powers the backoff queue to know how large the backoff should be. And so if I, and also there's max attempts. So if I reuse that machinery, then we would hit the max attempts. I don't know if that means I need max snooze, but probably not, because it's an intentional developer decision. The thing about errors is it's meant to be an unintentional error path. So you'd want the machinery of the system to be able to handle that for you. Where snoozing, you're taking control. So it's the same attempt. It's the same attempt, but we might need metadata on that it's a different... Oh, that's a good point. Should I record invocations and attempts as different concepts? I'm going to make a note of that because that might be something which I don't do now. Record attempt and invocation as different concepts. Okay, I made a note of that. Because that might actually be what's necessary, because then you'll be able to see that this is the 50th invocation, but we're still on attempt 1, which means that you haven't technically failed at any point and it's working as intended. But then you might say, well, if I've had 50 invocations calling this API, then maybe I need to change my code to be able to handle it better. So, for example, maybe they have a batch endpoint and we should use that instead. And so that allows you to optimize. Whereas if I just stayed on attempt 1 and it didn't increase it, you would just see everything being completed on the first attempt, which doesn't illuminate anything. The key thing is if what I'm doing is to work, like, return snooze, and we want to return because then that works well with the defer concept. We would need a sentinel for snoozing. There'd be a snooze sentinel. And then when we're handling the error for the job, we would check if we've received a snooze sentinel. A snoozettle. Yeah, so it's down here. Run en route. Resolve work error. And then we'd be able to check here if it's a snooze. We'd handle that logic here. So if the error is a snooze, then it's not an error, it's a snooze. And would handle it like this. Yeah, I'm doing it the old school way in this other file. I should do it this way, shouldn't I? Because it uses one less allocation. Though it is a test, so I don't know if it really matters. Can I not do that? Oh no, that's as type. Okay, let me just continue to think for a second. So there would be a concept like error snooze equals errors new. And this doesn't have to be that helpful of an error because it's not a real error. It's more of a routing concept. So we're using the error system as a routing concept. Marks a deferral, not a failure. That's a core part of the snoozing concept. A worker returns snooze and the duration. Which the dispatcher uses to reschedule the job. A snooze never hits the dead letter queue. Never hits the dead letter queue or advances the attempt counter. Yeah. I think I like this. It seems quite tidy. And hopefully we're going to have a lot of control options through the same error structure. So the only thing I'm just going to have to just think carefully before I proceed is, do I want to reuse any of the other structures of errors in this logic, such as wrapping errors or whatever? Like, maybe you want to give a snooze information. I'm thinking one thing I'm going to add temporarily because I'm probably going to be needing it later as we work is just a very quick error not implemented. Just because, you know, that's definitely going to come up. So a snooze error. I'm thinking what I might do is I might use this as an opportunity before we really dive into the code. To go to the toilet. But as part of the snooze error structure, we're going to have to pass down the so it will be as type. Let me see if this works. Be right back. Okay. One moment. All right. So that's a lot better. I was I've been having a queasy stomach for the past um hour or something, and suddenly feel a lot more relieved. Let's just say it like that. Um. So let me just remind myself of where I was. Um. So I was looking at the snooze control and flowing it through the error system. Um. God, I feel so much better in the stomach. I'm wondering if I should get into this new system just yet, because or if I should be getting into the time control logic first. Because time dot fluctuation. I'm thinking of not handling snoozing just yet, because it's going to want to ride off the implementation, the basically me extending all of the functionality of handling time in general. So I'm worried by doing this, I'm biting off. It's not necessarily biting off more than I can chew, but it's, jumping forward a little bit. And maybe what I should start with is making sure that a scheduled job is definitely not claimed before. So that you could say, where are we? Yeah, I'm worried that I got a bit premature with what I was concerning myself with. Let's comment this all out, because this is what we want to do, but I'm worried that as soon as we get into this, we're going to want to have all of this stuff linked up and scheduled up, and then we're just going to be creating a massive task just to get one test to pass. So I'm wondering if we want to start with the pending spec, a bit like this. So let's take one step back And let's make sure that a job doesn't get claimed before its time. Because I think that let's first validate. I have a feeling it will claim anything in the future. Because I feel like we're lacking control here. Scheduled job is not claimable before its time. So new store. Let's create a pending spec. Let's say job scheduled. Yeah, test email, sure. And then let's say spec dot scheduled at equals store dot now dot add time dot hour. Then let's enqueue it. Let's make sure it doesn't error. Then we can do store.get job state. And then that will be job scheduled. State error. So we can do require thinking of while I look at it. Increasing the size of this a bit more. Because I did accidentally mess around with the sizing. Okay. That might be a bit better. Then we can do require equal t scheduled state.status a future scheduled at inserts as scheduled not pending. versions, we have it down here. I wasn't very explicit with the last time I did this, but list job versions. I should have been more explicit with the errors above. Require len t. Let's copy this. History has the insert version only. Versions enqueued scheduled. Then we'll try and claim one. I think there's a linter which tells you if you're not filling these in properly, which I need to set up. And we want to validate that it didn't try and pick up any claims. A scheduled row is not claimable before its time. So the first question is, does this pass? And the 0th question is, did I get this working with Z so I can do that? Or do I have to do that? Fail. Yeah, so that was the problem that I was concerned about. That I believe we have the mechanism to handle this, but it's not wired up in the slightest. NQ spec. So this was what I was mentioning to begin with, that I was concerned that we just don't have enough control here. For example, priority is an easy get. So the core concepts that we're going to want is for someone to be able to say run at, which is technically different to schedule at, because run at is intent, isn't it? You'd also want to be able to say the delay. And the priority, as we identified, what I'm trying to figure out is, should we give control over the key? Because the thing is that at the very least, people may want to be able to specify a key for tracing purposes. May people want two keys? One for internal reference and one for tracing. Are those two concepts? I'm trying to figure out how the spec and the request differ and continue to differ. And making sure that I don't accidentally create two beasts doing the same job, or alternatively, which is in my opinion worse, one beast being used for two jobs. You want to have two things for two jobs, right? And in a request, you will want to be able to communicate the tracing limitations, right? You know, tracing, like correlation, your tracing token. I'm guessing one of the reasons why sometimes people will want to be able to provide their key is if they want to make it idempotent. But it would have to be communicated to the person that this has to be a unique key. Because it would bypass the key generation system. So I'm going to add these concepts and then consider stripping them away. So correlation ID will be for tracing purposes. This will be like your correlation ID is your trace token. Which probably in OTel we would want to make that a standard variable name. We currently have no way of this correlation ID is probably going to want to exist within the spec 2. which would mean we need to keep a record of the correlation ID. And it wouldn't be mutable. And it can be nil. And then we'll shove it in there for Postgres too. I've lost my... Here we go. Regenerate the dial. I'm going to need to add that to the queries too, actually, now think about it. But, say correlation ID string. Go to the queries. Insert job root. Correlation ID. And do the same thing in the Postgres. Close others. Insert job root. Is it down here? No, sorry. And then we can say correlation ID. Correlation ID. And then the same thing for Postgres. So we'll have to add this to the queries as well, but this is going to be what we're going to be able to, what we're going to use to allow someone to be able to keep track of the trace across the code base. Um, have optional text. So the issue is that we just give everything pending by default. That was the fundamental problem. Everything is pending. What we need to do is we need to check if this should be in the future or not. Because if this is in the future, then it shouldn't be pending. It should be scheduled. Initial status is sure if spec.scheduledAt.after now initial status equals string, if I can spell string worker domain status scheduled. And you probably why would that be a string? Oh, because that's the time formatted. Okay. So it's pending by default, but if it's scheduled in the future, then we'll say it's scheduled. And that should that already solve our test? I only really want to run the one we're looking at. The answer's no, for the record. Run. Sure. Okay, so that helps it to a certain extent because it was tripping up before here. Yeah. So we're giving it the right status now. The thing that is the problem, history, let me check my history has the insert version only. So we're not getting any item back when we do this. Versions, yeah, we're getting an empty object. Why would we get an empty object? Isn't it still creating it? Am I not seeing... Am I not seeing... Why would I not be able to query it? Okay, well, it's time to start playing with the debugger. List job versions. Let's go around again. How does this work? Okay. Step in. Step in. So now we're in the SQLite driver, right? So presumably the database query doesn't return anything useful. What I need with this Z setup is a way of being able to see what's in the database. But I think I'm running the database in memory. Am I dumb? Sorry, hold on. What? Am I dumb? I don't care about query or Postgres. I don't understand. Hold on. What I also need is, I don't like auto-jumping to the file, so I disabled that. But isn't there a way to, like, manually reveal in File Manager? Okay. Oh, no. That's my File Manager. Well, that's not what I wanted at all. Reveal in Project Panel. That's probably what I need. Confused. Confused why this would have a problem. Got a very slow mind today. Got a very slow mind today. Um... So, I mean, I do want this while I remember. I do want this slapped in here. And the same treatment will happen down here. Just while I remember. So, we do get here to insert the job. And it does it successfully. So it does append the version. I feel like I'm just being an idiot right now. Why would it find no versions? List job versions. Oh, I really am an idiot. Holy. Okay, I'm way too tired for this. Oh, Michael. I am way too tired for this. Okay, it passes. It's just because I was checking the wrong version. I thought there was some sort of like weird glitch going on in the system that I couldn't figure out. Okay, so that's the first thing. Um, and then we'd want the same concept here. With both concepts. I'm going to have to add that. There. Oh, come on. we'll just shove it down here for now. Correlation ID string. Oh, it was down here, sorry. What was it? It was insert locked. Come on, you can, your brain can wake up today, Michael. Come on. Okay. I think I forgot to do it for batching for Postgres. Batching for Postgres. For some reason, it sounds like a band name from the early 2000s. Oh, no. The concept's in the core. So that's already handled. Okay. So if it's in the future, it'll be scheduled. If it's now, it's pending. Or in the past, it's pending. Which now, I think we need to now add logic to be able to handle scheduled stuff differently. Because I think it might be running instantly. Because I don't know if it's not handled or if it's just treating like an alias for pending. I think it's just an alias for pending. Because we're going to have to wire this in now. What we're also going to want to wire in is start thinking of the priority system. Because we added that to the spec too. Or we already had that in the spec, it just doesn't work. If priority is less than 1, then priority equals default priority. Let's be specific. NQ priority. And let's make that 5. And this is how we're going to pass down the correlation ID. Like this. Anything else I need to populate right now? So this is how we're going to resolve the scheduled at. So right now, everything is always scheduled at now. But that's not true. That's not true. Because we have run at, which allows you to override that. So let's say if it is 0, let's handle this in a function. So let's say func decompose. Service resolve scheduled at rec enqueue request, and then we'll return a time dot Thursday. Isn't it going to auto format this space away? Then we'll be able to say if rec dot run at dot is 0 false, then return rec dot run at. This is how we're going to handle this. We're going to handle this like this. Resolve. I get really confused sometimes by the recommendations that I get from Zed. I guess it's Goplas, but it really does confuse me, the recommendations, I guess. Resolve scheduled at request. Return. And then this would be the default, which is what it is now. But if they give us a delay at, then we could say if rec.delay has a something set in it. I'm starting to wake up now, even though it's nearly 3 a.m. Return s clock now adds request.delay. Resolve scheduled at resolves all the possible scheduling configuration options for the starting time of a job. Takes rec which can configure the run at or delay. Returns time.time, which is the resolved scheduled at time. Of time to schedule the job. So now, if I had a full test, it would actually wait, because that should now be linked up, which it wasn't before. Which now means we can add some. We can start adding some control to the facade that didn't exist there previously. Worker facade. Let's say we could do Do I want it to be a service option or an enqueue option? I think it's an enqueue option. Then we could say with delay, d.time.duration with delay. Oh no, sorry. Then I do return func rec. Or maybe I do want to actually put it inside of the actual worker domain like that. So that's a bit tidier, isn't it? With delay, duration, time.duration. No, what am I doing? Sorry. With delay, with run at. And this would be time.time. Time.time. As such. And then the facade would just expose these. So with delay, then I can do. And get rid of these comments so I know how I need to do it. Worker domain with delay. Let's just say duration. With time. Run at. Let's just say run at. It looks a bit nicer than T. I don't like single variable names. With run at. Time.time. Okay, now we're actually starting to give people control over the running of things. Whereas before we didn't give them control at all. I'm thinking we may want to make a test. Let's create a new test folder. Service test.go. Func test build spec. Resolves schedule and priority. T testing T Gotta import it. Okay. So our base time will be, let's just pick something arbitrary. 20 or 26. What is it? July. Completely irrelevant. Not the, you know. What's this? Day. 8 hour. Let's just say 3. Min 0. 0. 0. Time dot. Let's just say UTC, even though it's not. Base dot adds time dot hour. Says create our test service. Test service. Should be able to find the service object. Clock.newMock clock. And then we'll give it the base as the start time. ID generator will be the normal default one, which is the UUID one. I think there's a constructor for it, isn't there? New. Maybe there's not. What do you take? You just take clock. Just take clock. Clock. Now they can share the same clock. Tick-tock. Bring this down. Real estate. So we want a table test for sure. That'll be like test cases. Struct. Always give them a name. Then we would loop over them. Test case. Range test cases. T run, and then that would be test case.name. Func. So we can say test service dot build spec, which is the function we just modified. So we would pass in the request here as part of our test case. Worker DTO dot enqueue request. Require.true. T spec dot scheduled at after scheduled at equal, and then we'll have something like once at time, and then we'll want something like once priority int 64. spec.scheduled at equal, what am I doing? Want at. Scheduled at equals want v. Spec scheduled at test case want at. So we're just proving that all of this resolves as expected and correctly. And we just need to do the same thing here, but for priority. Equals test case dot want priority. As such. So honestly, it should do this automatically for me. So I can just say priority. And let's not even use true actually here, because then if I wanted to do it for me, then I have to use equal, don't I? So then it'll just do that. So now we need to make the test cases. Immediate schedules at now with the default priority. Rec worker DTO enqueue request. And this would look like, how can I tidy this up? Okay. So it doesn't matter what the kind is. So I don't even know if that will even be a concern, but we want to make sure it doesn't error out on us. I guess if guess I probably don't need to set anything else. Okay, so it'll just be the blank test. Now. Five. Default NQ priority. Okay. So pass. If you want to set a relative delay, let's say do 30.time.minute. Okay. I think I'm going to continue to flesh these out afterwards, just to make sure we have everything working, but I think it's all perfect. So I know the next thing. Um, so that resolves this issue, and it should be mostly fully threaded through. So now you have control over the starting times of jobs. The next thing is we need to create an end-to-end test on that concept. Let's make a new test suite called schedule that, where we just worry about all the scheduling tests. But it's going to be another type of run test. So we're just basically full flow testing what we just did. Test runner. Delayed jobs runs on time, not early. Early being now. Right? So we don't want it to run now. We want it to run in the time that we asked it to run. Now, I don't know, and I don't think this is going to be one of those things where, like, millisecond precision is necessary for how we do timing. I'm going to just want to copy this from these tests. We're going to probably just reuse all of this recording worker stuff. Oh, I already got my title, didn't I? Oh. Okay, time to get cozy. Boarding worker. Worker register. Worker node. Require. Blah, 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 blah. Worker in queue. And then this is when we would say worker dot with delay. And then let's just say well, let's save that to a variable so then we can reference it if I should really go back and properly. I'm not trying to spell NQ right now. Because we should be able to say require greater or equal T time dot since just say enqueued at time dot now. I don't really like doing what I'm just doing because it's could be flaky, but I guess providing it's just greater than, we're just validating it's been processed greater than this period. So if there's load on the computer, it should always be still fine. So if time.since enqueued at is greater than delay, then it ran successfully in the future. A delayed job ran before it was done. Now, right now, does that fail? Because my assumption is it does fail. That's why we write these tests, so we don't have to assume. Because when you assume, you make an ass out of me and you, or you and me, the other way around. Okay, I wasn't expecting it to hang. I was expecting it to hang because what that means is that I was wrong when I said that right now it handles both pending and scheduled as the same thing. Because what this means is we're just never handling scheduled right now at all. So if we can start handling scheduled, if we can just start handling scheduled, what we probably need to do is we probably need to have a system which promotes scheduled jobs to pending jobs. So once again, we're in like a thought decision process. Do scheduled jobs become pending jobs and then get executed, or do scheduled jobs just get executed immediately once they've received their time? An argument for converting them to pending jobs first is it will help with observability. And by having a one single clear path of action will make it clearer when you're debugging what happened. And it'll make it clearer with the interface. And it'll make it clearer with having a single flow for like, when you're picking up claims to only pick up, in the right batches. Because ultimately, the way that our system is designed is to never be that time sensitive. And that's by design. Because when you claim stuff, you only claim on pending. You never claim on scheduled. So but I put it as count claimable jobs here for some reason. So if things have to become pending, I think that's correct. Things have to. Yeah, I think that's correct. Things have to become pending. Because our system isn't very time sensitive anyway. By design. And the reason why I say that is, first of all, I'm using Golang. So it's a garbage collector. So it's not inherently a low latency language anyway. And secondly, we pick jobs up in a batch on things that's ready to be done based on their priority, not based on the time that they asked to be done on. So we probably want to go via pending, even if it slows down how long it takes to pick up a job. And then it becomes clear when something goes from being scheduled to being pending. And then we only have one flow that handles pending jobs. And it becomes clear once a scheduled job is successfully within the bucket of jobs to be picked up, because it's no longer scheduled. So I'm thinking that is what I want to do. So we'll need a promotion system. And the promotion system could either be based on database events, though probably not, or the promotion system, at least to begin with, could just be a ticker. So, like, let's say we go to our ports. Let me just have a look very quickly. Because we would probably want to be able to say something like, with promote interval and make it really short for the purpose of the test and do something like 50 times time dot millisecond. Prompts with promote interval. Something like this. And then we'll have it, for the purpose of the test, ultra fast. So default promote interval. Just for now, let's just slab some stuff in. I'm not even 100% definite that this is what I'm doing. Default promote interval. Which would mean that in our store, we have claim due, and then there would be promote due. Context, limit int. And it will just, in one fell swoop, promote everything in the store, which is due to be promoted. Promote due. Currently scheduled. I'm wondering if... How do we currently handle retriable? Because retriable is another type of delayed concept. Let's just keep it like this. Promote all jobs which are currently scheduled to being pending. Up to limit. And then we'd have to implement this. Where's my new method? Claim promote. What was it? It was promote due. Promote due. Panic unimplemented. And we'd need it for the otter too. Where did you put it? Promote Jew. Here we go. I'm going to get rid of the comment just because otherwise I might get confused that I've already commented it. I do not like where it's put these functions. At the very least, let's put it down here. So claim candidates. So we're going to want to have promote due candidates. Promote candidates. I'm going to need some params here. Candidates. Params. And then this would be like promote candidates row, an error. So where do we define these? Down here. Promote candidates params. Promote read. Promote candidate row. So it'll be job ID. Scheduled at. I think we can ditch most this. I think we can ditch most this. So now we're going to have to start implementing it. I'm going to want some queries. Database queries. Let's do SQLite first. Claim due. How to do it? Oh, claim candidates. Okay, so we're going to want something like that. This is going to be promote candidates. So I decided we probably only really care about a few things here. Job ID, I don't think we need the join. So job ID, priority, scheduled at attempt. From job index, let's drop the join. I think it's that's not really appropriate here. Where status is, so I did mention that retriable probably should be handled in the same flow. Let's say scheduled retriable. I'm going to have to double check how I spelled that. I think this status isn't linked up yet. Retriable. Or is that just the code I just wrote? Retriable. This is all looking good. That looks good to me. And then we want to have the same concept, but for Postgres. If I can open the right file. Um, so with Postgres, we have to actually put in the dollars. And then we can do this skip locked thing too. Oh, right. Well, if I'm going to do that, then I have to do this, don't I? Regenerate the dial. I fucked up. Internal worker domain config. Default promote interval. Didn't I just set that? I swear to God I said this. Or did I call it something? Interval. I've got to add the missing methods, or it lets me generate. Okay. I fucked up. Nothing new there. Oh, yes. I forgot that all the tables in Postgres prefix with the database. There we go. Because obviously with SQLite, I can create a different file per database. Whereas with Postgres, you would want to reuse the same database for multiple databases. Okay. So now if we zilch this so we can empty my brain again. It's time to start trying to implement this. Promote Jew. Well, we should probably actually just start with doing it for the driver itself. So promote candidates. Scheduled at params.scheduled at limits params.limits. If we have an error, we can just return it. Is that how I normally handle it here, or do I normally wrap the errors? I don't remember if I just blind return here. I just blind return normally. Okay, maybe in the future I need to start wrapping the errors here. I don't know. It probably doesn't make... Just trying to think. Let's just blindly return them without wrapping for now. Out. Make. Dalcore. Dot. Promote candidate row. Len. Rows. For I. Range rows. Out. I. Dalcore. Dot. Promote candidate row. And then we can just populate all of the data. Scheduled at rows I dot scheduled at, what was the other ones? Attempt and priority. Attempt rows I's dot attempt priority rows I dot priority. Return out nil. And now it's the fun job of doing this everywhere. It's the fun job of doing this everywhere. It's the only difficulty. Well, does this just work? Yeah, I think so. And then, for Otter, promote Jew. This is going to look a bit like, min, max, limits 1. This will be claim, batch, hard cap. We need to use the mutex lock. defer d.mu.unlock. Now we're probably going to want a similar structure to this. Candidates, job entry. So we need to change this because what we're looking for is if they're pending. No, sorry. If they're scheduled or if they are candidate status string worker domain retriable. Now, I'm evidently an idiot. Because why? Oh no, you're happy. You're happy. Is 0. Yes, it's not deleted. It's scheduled. It's not scheduled after now. Yeah, that's correct. Because we want something that's eligible to be a candidate, an eligible candidate. Okay, well, that looks all good to me. So then we go sort stable func. This is all going to be the same, isn't it? That's all going to be the same. Then we're going to limit the batch again. Perfect. Then this bit will change to be good question. Is going to want to create a new entry. So it's going to be one. It's going to want to be something like and then d.append version entry worker DTO event promoted. And then we become pending. And we're gonna have to do this logic for the DAL core. Worker domain status pending. Priority is current stop priority. And then it's going to be scheduled at, is going to be current dot scheduled at. And then we return the amount of entries that have been promoted. So we just do sorry. So for Otter, that is a complete implementation. And we're going to have to implement that here too. Same logic. Zero. Promote due. Promote candidates. Promote candidates param. Promote candidates. Promoted. Was that what I said? Promoted? Promoted. Job ID promoted. This becomes pending. Status pending. Priority scheduled at attempt. It's not claimed. Attempt doesn't increase. So that can just be like this. Promoted. Priority schedule at attempt. It's now pending. It's got the job ID. I failed to append promoted version for job. Claim candidate to record. What the hell was this? Well, the thing is I don't think I care. Or at least if I do care, it's not yet. Maybe in the future I'll care. Fail to promote jobs. Because it could be that, candidates. Candidate count. It might be in the future that I want it to be event driven, and so maybe I do care in the future. And I do want to actually pass down this information. So then I can make it event driven, and then the benefit there is this could immediately trigger the claim due process immediately. But for now, let's not worry about that. Let's think about what I've done so far. This is in recovery.go. That makes no sense. So I'm thinking the default promote interval will want to be a very small number 2. And then for our test, we'll make it even smaller. So this will be twice a second. Default promote interval is how often the promote loop scans for due, scheduled, or retryable rows to promote. I'm trying to not use the word promote twice. Yeah, 2 pending. Because by having this really low, it should mean that on the next tick, we essentially pick up these jobs. So we're not out by too much. So we have a promote interval here. Promote interval is how often the promotion scheduler runs to promote viable scheduled or retryable jobs to pending. So we have our, is it in here? We have our spawn loops. Because this is probably going to be another loop. Loop to loop. Spawn loop. I'm pausing for a second. Because let's say we have 50 worker nodes. The loops are going to be looping all over the place, aren't they? And we may actually put pressure on the database by having all of these loops. Though maybe the way that it will work is I might have some sort of master node system, but not necessarily for I think I'm gonna think of the distributed side when I come to it and just get it working. That is the primary goal, right? So spawn loop. Um, so I don't think we need an entire service for this. It would probably just be something like run promote loop. Func service, right? Service run promote loop. Context. Let's grab our ticker. So I need to get access to the promote interval from the service struct. So that's going to have to be made available to me. Um, defer ticker.stop. And then we'll just put ourselves in a loop. Handle the context shutdown. Ticker.c. Let's decompose this. Decomposition. Let's say promote. I think I call it claim once. No, I don't call it claim once, don't I? Or like run once. Say promote job. Promote jobs. We've got our logger. s.store.promote due context default. I'm going to want to have the default promotion batch. Let's just put it to 100 right for now, and then we'll I'll extract the magic variable afterwards. So this returns the count, correct? He returns the count. The count and the error. Promoted. Count. Promoted. Just promote. If error doesn't equals nil, L.warn. Promote pass failed. Logger domain error. Remote pass failed. If nothing happened, then nothing happens. If something happened, we can add that to our trace logging so we can debug it. Promote due jobs to pending. Logger domain int promoted. If error we can hit the notify system to wake up the loops after promoting. This will be every queue. It's a bit heavy-handed, to be honest with you. But I might kickstart it. So, we... Oh, nice. I have a panic. It's probably me just not initializing something that I should initialize. I think I'm getting a bit tired, so I might just leave it here anyway and find the thing that I need to initialize. I think I'm fairly happy with how we're proceeding. And I'm gonna probably call it here. It's apparently 4 a.m. So I'm probably gonna call it here. And I'm thinking when I next pick this up, the next thing to focus on is the fact that right now we error out if someone duplicates a key. I'm thinking what we want to do is actually just take ownership of it, and the two jobs will collapse into one. And so we're slowly making the system more robust, and I think that's going to be the next tranche of work where the priority is making the system more robust and more extensible. All right. I'm gonna call it here. All right. Thank you to everyone who joined, and I hope you'll have a nice evening.